Hi, we're back with a new section, Machine Learning. This section is a hands-on introduction to some of the most basic methods in machine learning. These methods are routinely used by data scientists. We'll use these methods with Scikit-Learn, a popular and user-friendly Python package for machine learning. Let's move on to the first video, which will let you get started with Scikit-Learn. In this video, we introduce the basics of the machine learning Scikit-Learn package. This package is the main tool we'll use throughout this section. Its clean API makes it easy to define, train, and test models. We will show here a basic example of linear regression and the context of curve fitting. This toy example will allow us to illustrate key concepts such as linear models, overfitting, underfitting, regularization, and cross-validation. So what we're going to do is, we'll generate a one-dimensional dataset with a simple model, including some noise, and we will try to fit a function to this data. With this function, we can predict values on data points. This is a curve-fitting regression problem. You can find all instructions to install Scikit-Learn in the main documentation present at this link. Anaconda comes with Scikit-Learn by default. But if we need it, you can install it manually by typing in the terminal conda install scikit-learn. Done. As you can see, that all packages are installed. Now, let's get back to the Jupyter Notebook. First, let's make all the necessary imports. So here we import NumPy, SciPy, .stats, sklearn, .linearmodel, and matplotlib.pyplot. We now define a deterministic nonlinear function underlying our generative model. Def f of x and return np.exponential of 3 into x. Next, we generate the values along the curve on 0, 2. Let's write x underscore tr equals np.line space 0, 2, 200. Then do the same for y, but here we pass the function with the value x underscore tr. Now let's generate data points within 0, 1. We use the function f and we add some Gaussian noise with these two lines of code. Let's plot our data points on 0, 1. Awesome! In the image, the dotted curve represents the generative model. Now we use Scikit-Learn to fit a linear model to the data. So here's the code to do that. Here, there are just 3 steps. First, we create the model that is an instance of the linear regression class. Then we fit the model to our data. Finally, we predict values from our trained model. We need to convert x and xtr to column vectors, as it's a general convention in Scikit-Learn that observations are rows, while features are columns. Here we have 7 observations with 1 feature. In the next cell, add these lines of code to plot the result of the trained linear model. As you can observe, we obtain a regression line in green here. The linear fit is not well adapted here, as the data points are generated according to a nonlinear model, which is an exponential curve. Therefore, we are now going to fit a nonlinear model. More precisely, we'll fit a polynomial function to our data points with this block of code. So we still use linear regression for this by pre-computing the exponents of our data points. This is done by generating a Vandermonde matrix using the np.vander function. Let's execute this code. Here we have fitted 2 polynomial models of degree 2 and 5. The degree 2 polynomial appears to fit the data points less precisely than the degree 5 polynomial. However, it seems more robust. The degree 5 polynomial seems really bad at predicting values outside the data points. Look for example at the x greater than or equal to 1 portion. This is what we call overfitting. By using a too complex model, we obtain a better fit on the trained dataset, but a less robust model outside this set. We'll now use a different learning model called ridged regression. It works like linear regression, except that it prevents the polynomial coefficients from becoming too big. This is what happened in the previous example. By adding a regularization term in the loss function, ridge regression imposes some structure on the underlying model. Now let's add the code to test this. Done. Now the ridge regression model has a meter parameter, which represents the weight of the regularization term. We could try different values with trial and error using the ridge class. However, Scikit-Learn provides another model called ridge-CV, which includes a parameter search with cross-validation. In practice, this means that we don't have to tweak this parameter by hand. Scikit-Learn does it for us. As the models of Scikit-Learn always follow the fit-predict API, all we have to do is replace lm.linear regression with lm.ridge-CV. Let's go ahead and execute this code. As we could clearly see, this time the degree 5 polynomial seems more precise than the simpler degree 2 polynomial, which now causes underfitting. Ridge regression mitigates the overfitting issue here. Observe how the degree 5 polynomial's coefficients are much smaller than in the previous example. That's all for now.